Our sun, a celestial inferno, has bathed our planet in warmth and nurtured life for millennia. But even stars have a lifespan, and our sun is no exception. Over billions of years, the sun has been steadily fusing hydrogen into helium in its core, releasing the energy that powers its brilliance. Yet this process cannot last forever. As the sun ages, it embarks on a dramatic transformation, setting in motion a cosmic dance that will reshape our solar system. The sun's core will eventually exhaust its hydrogen fuel. As this happens, the outward pressure from nuclear fusion will diminish, unable to counterbalance the relentless inward pull of gravity. The core will begin to contract, heating up under immense pressure, causing the sun's outer layers to expand dramatically. The sun will begin its metamorphosis into a red giant, engulfing its closest planetary neighbors. The first victims of the sun's expansion will be the innermost planets, Mercury and Venus. Mercury, the smallest and closest planet to the sun, will be the first to succumb to the sun's inexorable growth. Venus, often called Earth's twin for its similar size and mass, will meet a similar fate. As the sun continues to expand, it will eventually engulf the orbit of Venus, turning the once bright planet into a wisp of vaporized rock and gas. The inner solar system will be reduced to a swirling inferno of superheated plasma. But the sun's expansion won't stop there. Its fiery reach will extend beyond the orbit of Venus, setting its sights on our own planet, Earth. As temperatures on Earth continue to climb, the very rocks that make up our planet's crust will begin to melt. Volcanoes, dormant for millennia, will roar back to life, spewing molten lava and noxious gases into the atmosphere. The Earth's once familiar continents will be reshaped, their outlines erased by rivers of fire. The once vibrant biosphere will be extinguished, leaving behind only a barren, lifeless wasteland. But even as the inner solar system is consumed by the sun's fiery expansion, a glimmer of hope emerges in the outer regions of our planetary system. Mars, the red planet, may experience a surprising twist of fate. As the sun expands, its habitable zone will shift outward. Mars, once a frozen wasteland, might experience a temporary reprieve from the cold. The same forces that could temporarily warm Mars would also strip away its atmosphere over time. The sun's intense radiation would bombard the Martian atmosphere, energizing molecules and causing them to escape into space. This atmospheric loss would eventually leave Mars a barren, airless world once more. Yet, even as Mars's window of opportunity closes, another celestial body in the outer solar system might be on the cusp of a new beginning. Europa, one of Jupiter's largest moons, has long intrigued scientists as a potential haven for life beyond Earth. Covered in a thick shell of ice, Europa harbors a vast, subsurface ocean of liquid water. The sun's transformation into a red giant could dramatically alter Europa's prospects. As the sun's energy output increases, the outer solar system will experience a significant increase in temperature. Imagine a world where the surface is a vast, shimmering ocean, dotted with islands formed from the remnants of Europa's icy shell. Volcanoes, fueled by tidal forces from Jupiter, could erupt beneath the waves, releasing heat and nutrients into the ocean. This dynamic environment could provide the perfect conditions for life to arise and flourish. However, Europa's potential transformation comes with its own set of challenges. The lack of a substantial atmosphere would leave Europa's surface exposed to the full brunt of the sun's radiation. The sun's outer layers will be ejected into space in a series of powerful pulses. These ejected layers will form a vast, glowing shell of gas and dust known as a planetary nebula. The planetary nebula will slowly dissipate over thousands of years, seeding the interstellar medium with the building blocks for new stars and planetary systems. At the center of this cosmic spectacle, the sun's core will remain. Having shed its outer layers, the sun's core will be exposed as a small, dense object called a white dwarf. A white dwarf is the remnant of a star's core. composed mostly of carbon and oxygen atoms packed incredibly tightly together. Although incredibly hot, a white dwarf no longer produces energy through nuclear fusion. Instead, it slowly radiates away its remaining heat over billions of years, gradually cooling and fading from view. As the Sun's gravitational grip weakens with the loss of its outer layers, the orbits of the remaining planets will shift. Some planets may be ejected from the solar system entirely, flung into the vast emptiness of interstellar space. Others may find themselves in vastly different orbits, their paths around the Sun altered by the changing gravitational landscape. The asteroid belt will be particularly affected. Asteroids, once confined to relatively stable orbits, will be scattered by the gravitational perturbations. The once ordered ballet of our solar system will become a chaotic waltz, while the inner solar system will be largely consumed by the expanding red giant. The outer solar system will experience a different kind of upheaval. The icy giants, Uranus and Neptune, will see their orbits expand as the Sun's gravity weakens. The Sun's weakening gravity will loosen its hold on the Oort cloud, potentially sending showers of comets hurtling inwards towards the Sun. These icy messengers will carry with them clues about the conditions that prevailed during the formation of our planetary system. The Sun's transformation into a white dwarf marks the end of its main sequence lifetime, but it also heralds a new chapter in the story of our solar system. The white dwarf Sun will continue to illuminate the surrounding space, casting a faint glow on the remnants of our planetary system. The cosmic dance will continue, albeit at a slower, more stately pace. The planets that remain will continue their celestial ballet, their movements a testament to the enduring power of gravity. The future of our solar system will be shaped by the interplay of these cosmic forces. The cosmic dance of creation and destruction, of birth and rebirth, is a never-ending cycle. Our solar system will eventually fade into the cosmic background, leaving behind only the faint echo of its existence. The atoms that make up our bodies, forged in the hearts of stars, will be scattered into the interstellar medium. The legacy of our solar system will live on in the very fabric of the cosmos. And so, the cosmic dance continues, a timeless ballet of celestial objects, shaping the universe we know and inspiring us to explore the endless possibilities that lie beyond our world.